3, 2, 1. Thank you, Mark and Dave. Mark Heidemann from the ASHRAE committee chairman, and Dave Anderson from here at the University of Michigan. Mark, do you want to say a little bit what you do with this particular document?
Well, this document came out of a research project called the RP 1455. So as a principal investigator on RP 1455, and then made the or recommended as the committee chair and approved now for Guideline 36. And Guideline 36 currently only has the RP 1455 sequences in it, which is the air side, the dry side. But there are other research projects for TC14, that's the controls committee at ASHRAE, that will be investigating wet side sequences and others. Another related research project deals with ASHRAE standard 62.1 in the multiple space equation, and those will eventually get rolled into Guideline 36.
Okay, great. Thanks very much. You are calling from Atlanta. Where's your location, Mark?
No, we're Taylor Engineering is located in the Bay Area. We're in Alameda, California.
Okay, so
we're going to be at the meeting in Atlanta, and on Monday we'll be having a net meeting that all commenters can participate, in interested parties in our deliberations over the advisory public review comments received.
Okay, so this is your organization then, right? Okay,
yeah.
Good. And then, okay, David, do you want to say a little something about what you do?
Oh, sure. Well, I work at the University of Michigan, and I work with the building automation systems here. And I do half my time is kind of in the lead mechanical engineering role, and the other half is in the building automation system analysis role. And I've been working on reviewing some of these standard proposals, and I had a few comments that I had put in, so maybe we can discuss this.
Okay, great. Mike, I'm going to try to make you the presenter, and I'm not seeing your pin coming in, but let's make sure maybe that's not necessary. So,
I've got it, yeah.
Do you? Okay, so it's your airplane now, Mark. Go ahead.
Let's see. I want to make sure I get the right screen. This one, click the right one. Okay, so actually, let me drive the screen, but Dave, since these are your comments, why don't we talk about the issues that you have? I mean, let me know which one you want me to open up, and we can go to it. Or do you want to just go from?
Actually, I went through all these. A lot of these were from Stuart. It looks like mine. I guess when I put mine in, I didn't quite follow the standard way of doing it, I think, because I had PDF attachments we had printed out the specification, and I marked up different sections with comments, and then
I have those in with these comments. So where you had an attachment that was uploaded to the ASHRAE database, I've attached it to the back of the comment.
Oh, okay.
You'll see, if you look at the bottom of the screen here, there's only one page, but some of the other ones have attachments. There's a second page, and I've got the attachments on that. I just did that for the committee to make it much easier for them.
Well, which is fine. I guess one of the comments I had was about the addition of outside air temperature sensing to the air intake of fan systems, and I didn't see that one listed, so maybe I missed that.
Again, we received 15 comments from you collectively, and that's out of 113 comments total on the standard. And I've got all 15 here, but I don't have them all memorized. So
I think these are ones submitted on Stuart Fisher's behalf by Mike Anthony. Mine were submitted. I submitted them directly.
Oh, you did?
Yeah,
yes.
That's where I was going to jump in and say that Stuart's relatively new to the process. It's not uncommon for mechanical engineers they need time to get used to the idea they can actually write some rules for themselves. So I just give them a document. I let them write in the natural way possible. So you'll see in the package that I gave you scans of Stuart's comments, but Dave is more familiar with this process, and so you could basically cut over to his material right now and ignore mine.
Okay, I'm sorry, I wasn't aware that we were doing that. So let me just see if I can find this quickly. GBC 36, comments or views. You don't happen to remember what your commenter number is, do you?
I don't remember, but I could look it up.
Let's see, I'll look this up too at the same time. Tag list, comment summary. Okay, and it's Dave, Mike. Is it Dave or David?
David.
Okay.
The email address, if that helps, is davidba@umich.edu.
So there you go. So it's a comment 11, comment 1. So I'll pull that one up for you. Commenter 11, comment.
And if I'm not mistaken, Dave, you just did one comment, but it was a markup of the document itself, or did you key them in one by one?
No, I attached the comments. There were 5 pages that were that had.
Yeah, there's these 5 pages attached, and you can see we've got 7 pages total. So the comments were, okay, marked up comments attached. The comments are about problems with the sections as shown, but do not have strikeout language. Sequence call for static pressure resize. Okay, welcome. Okay, so let's go on to the next page. And do you want me to make this a full screen? Is it easier for you?
It's fine for me. Well, actually, the other way was better.
Oh, you want a width? Okay.
Yeah, that's more legible on my screen. Okay, so this was a temperature sensor at outdoor air intake, and it looked to me like it was saying that you're choosing the outdoor air sensor closest to the unit, which if you have them, that's fine. But what we do is we have a master station that we keep calibrated, and then we share that amongst our fan systems, our buildings. And so for us to have sensors in each air intake, we have a lot of fan systems at U of M, so it could be $1.5 to $2 million worth of sensors if we had adopted this over that period of time that we installed those systems. So we didn't think it should be prescribed that you have to have an outside air sensor in each outside air intake of each fan system.
Yeah, I don't think anybody would disagree with you. Where you have a good outside air system sensor, we also, as our standard when we do our own controls, typically look to see if there's a NOAA weather station nearby, and we may have multiple outside air sensors at each of the air handling units, but we compare it to the NOAA reading and do a maintenance alarm if they're far off of what the local weather station has. The same would be true if we had a high quality, like an aspirated outside air sensor with a radiation shield or something on the building itself. We would compare all of the other air handling unit intakes to that to see if they were in fact drifting and be able to alarm on it.
Sure.
So again, this standard is written, or the guideline is written with the idea of providing the best of class practice. But again, there's a wide range of practices, and certainly having one very high quality sensor available for outside air for economizer use and other controls, reset controls, is something that would be very good. So I think we agree with you. And if you do have a if you do have one high quality, sensor out there and you're using that for all of the air handling units, I would agree that that would probably be sufficient.
Okay. Yeah, we just didn't know if it would start speccing it in new jobs just because it was standard gets adopted and becomes common practice to do that everywhere.
Well, there's a couple, if you don't mind me, gentlemen, is in a campus environment where you have clusters of buildings under a single ownership, that configuration, very often it's not contemplated in a document like this. And the other item of interest is the tendency for a guideline to be brought into a standard to be brought into a code, and into a code into enforceable law. So the path from a guideline to enforceable law, which is essentially on your balance sheet for first and running costs, can be a very short and fast one. So I would just recommend if there's any language in there. I think you probably say farther upstream that we're offering a best in class, but we saw this as market making for, I won't say it, but David will, because I deal with 100 standard suites, and in each of those 100 standard suites there's 50 documents, and in the 50 documents there's another 500 products and services, moving parts in there. You get to know what market making looks like. So as long as some language is put in there and to safeguard, that strikes me as a fair compromise. That's all I have to say.
And I've got this noted, that having one high quality sensor is better than multiple distributed sensors, and particularly for a campus. And
we recognize there's a lot of rooftop unit type work that gets done out there, and a lot of them may already have sensor for outside air that's part of the package unit and so forth. So we understand, our size isn't the same as everybody's size, but thanks for considering that.
Okay, so let's go to this one here. I don't know if I can actually turn the screen on this, but it says a table of expected values based on airflow measurement.
Yeah, this was for variable. We found that when you have a sensor, a DP sensor across a filter for an alarm, that that expected pressure obviously changes as you ramp up or speed up or slow down the fan. So we'd like to have that be part of the specification for the alarm limit. So,
okay, DP versus airflow or something?
Yeah, yep. Otherwise we get false alarms and it becomes meaningless and everybody turns it off and ignores it, and so we wouldn't put it in anymore.
Yeah, the other thing you can do is usually on when you're first starting up the fans, at some point you're going to full throttle, certainly like on a morning warm-up, for instance. And you could also filter the alarm for that condition where the fan is at or near its full design speed. Then you look at the condition. You enable the alarm per filter. So there's different ways of doing it.
Yep. And whichever way is the most efficient and easy to set up and whatever, that's what would be nice to have that kind of added into this desired sequence of operation.
Okay, this is great. Sorry, I have to type, make sure that I get my whatever we talk about here. Here, flow. Okay, great. So you have something in there about humidity. Obviously, in certain climates and definitely for certain facilities, you've got a humidity sensor, see, on the discharge side. You want to talk about?
Yeah, sorry, I should have scratched that out. I realized that. I mean, that's an additive thing that you don't have everywhere. It just depends on whether you need humidity control or not. So you can ignore that.
Okay, sorry. The Iowa Energy Center did a great study on, it was under the NCBIP program. They did a great study on humidity sensors, and they're terrible. They drift like crazy. Out of all the sensors that they got brand new from 2 different manufacturing lots for each of the manufacturers and product numbers, they did chamber studies first, and then they put them in the outside air intake of their unit for a year, and only 2 were able out of the box to match the manufacturer's stated accuracy. So we tend to avoid
those were.
Yeah, ACI and the Vaisala HM series.
Oh, good. Yeah, the Vaisala ones we found were very accurate.
Yeah, if you're interested, I can send you the a presentation from the Iowa Energy Center on that, and also the reports, and they name the names of the sensors.
Yeah, that would be great.
Okay. I don't know if I've got your email address, but I'll definitely send it to Mike.
Okay. Yeah, just this David J. Baker Apple at umich.edu.
If you're copied on the invite, I'll send it to
He is. Yeah.
Okay, good. So next issue, trying to be respectful of your time. Table of expected normal values.
Oh, that was the same as the other one.
Okay. So we just talked about that. Good. So tell me where you want me to look. Oh, down here, VFDs. Oh, sorry. VFD low limit for hardwired variable speed drives should have minimum speed entered through local VFD interface and not rely on the MCS. Protect against low frequency vibrations. Yeah, what
I
happened
saw another comment about that earlier, and I guess I would say that I don't know that this necessarily has to stay as a comment. Then you were talking about using 10% or so and not having problems and so forth.
Yeah, we have to fight this all the time with owners just because of perceptions out in the marketplace. But anything that's reset by demand has a near cubic curve. So the inlet guide vanes on the variable speed for centrifugal chiller, for instance, variable speed for where you're doing condenser water reset aggressively. For fans, when you're doing supply pressure reset by demand, and also with pumps, where you're doing supply pressure reset by demand, you follow pretty well a pure cubic curve, and you don't end up either in surge nor do you end up in having a lot of heat in the motor. So if you look at all these sequences, they're all demand-based resets on supply pressure, for instance, and also when we get to the wet side, which is not part of this document yet, we'll do that with head pressure control. But for fans and pumps, if it's a reset set point by demand, there is really no issue of going as low as you can go, the slowest that keeps the pump or the fan, turning. Of course, once you get down to about 5%, there's almost no energy there anyway. And we've talked to motor manufacturers, Baldor, U.S. Motors, others, and we've talked to the drive manufacturers, ABB and others, and we've done black box radiation models to show that there's no real energy there. You can't ever get the windings too hot to actually destroy the motor. And then we have field experience. We've got relief fans, and there's one in the Cathedral Chrysolite in Oakland that has relief fans that have been running at 3 hertz or something for years. We've got trends on that thing. No motor failures, no VFD failures.
Yeah, actually, I was rereading through this comment, and what this was about was that the comment was more of we shouldn't rely on the BAS system to provide a safety. If the intent was to have a safety for the lowest speed kind of thing, that should be done at the drive itself. And of course, for hardwired VFD, it says it's the lowest speed command sent to the drive by the EMCS. So it made it kind of sound like we would have a lowest speed stored in building automation system rather than at the variable speed drive.
And it would routinely refresh back down there. You can do it one way or the other.
So I guess we would consider it, whoever sets up the variable speed drive should be setting up finding frequencies and so forth where it might be unstable and making sure that it can't operate under any unstable areas.
Well, we're talking about minimum speed here. We're not talking about stability in operation across the range. So if you're worried about like blanking out a harmonic frequency, something that's would cause vibrations on the fan, at a very specific speed, you might get shaking on a fan or a pump. That's a completely different issue, and it's not even addressed in this document.
Okay.
All we're talking about is minimum speed. So
and
the idea,
that's fine. We can. You don't have to do anything with that comment then.
Okay, great. Great. So next one, let me go up there. Trim and respond. So it's all the trim and respond stuff.
Yeah, I was reading through this, and I was reading through your, kind of the test and response kind of deal where you adjust and check every so often and go up or down. We kind of are doing the same thing when we look at we use a loop to keep the most open VAV damper at 90-95%, depending on the area. And that's worked really well, but I was reading through some of the other comments and the things that it's being used for, and certainly there's reason to think that there may be some advantages to what I saw written in the new control sequence.
Yeah, so this is something that
basically
actually is ALC has a block that does this, and we've done it with Siemens and Johnson and many other controls. It's part of our internal standards. But one of the things we like about this is if you have something that's really important, you can use that thing that's called the importance multiplier, and it actually gets more votes. It can, if you've got like a data center or some mission critical space, you've got a lab or something that you want to make sure is satisfied, you can give it a higher importance multiplier, and it basically gets a larger vote than all of the other VAV boxes, or coils if you're using trim and respond on coils as well. And then the other thing is, if you've got a rogue zone, so let's say you've got a VAV box serving a small office or a classroom or something, and somebody goes in and throws in a bunch of servers in there, and that zone doesn't have enough air to satisfy the load. You don't want it driving the entire building all the time. And so one of the things that we look at under item B is request hours. We track the request hours, which is the number of requests from each zone times a time interval, and you accumulate that, and then on the EMCS screens you display it, and you can quickly see the zones that have very high request hours, and you can alarm on those and put them on a maintenance alarm, and then the facility guys know which zones are having problems. And then go out and look at, maybe it's a damper that's stuck. I've actually seen insulation going into the inlet side of a VAV box. Again, many times we look at the high request hours, we go out there and somebody's dumped a whole bunch of equipment in there and not rebalance the system or put in a larger box or anything like that. So it really, one of the things that's nice about trim and respond as opposed to doing it as a PI loop is it gives you feedback on the demanding zones. And it makes it much easier from a facility side to go and fix them.
Yeah, and that makes sense. We were approaching it a little bit different from the aspect of we trend and then we also check and alarm when we get these groups of, we also put it into groups basically like zones, and then we take the maximum damper position from each of those and set the set point to 90%. But then on the other side of that, we also have if it goes above a certain percent for over a certain amount of time, then we alarm it to say there's something wrong, we're not satisfying that group anymore. So it's kind of a similar type of thing, but it doesn't actually, it says basically we have to have everybody satisfied rather than some are more or less important than others. And you know, I can see where there could be some advantages to doing it this way. So
the other thing about trim and respond is that if something gets wound up too, you can have a nonlinear response. So again, we do a lot of data centers, and obviously as you begin to, you know, get zones where the temperatures are rising, it wastes a lot of energy, particularly because the fans on servers are as much as 15% of the overall energy use of the server once they're at the high speed. So you want to keep them below that for an energy efficiency. Plus, again, you don't want to get the servers too hot because you could have failures. So we do, like, you know, a trim and respond that has, you know, maybe one vote for more pressure or lower temperature when the temperature is close to like 78 or 80 degrees, and then if you get above that, we might go up to 5 votes or something to get the trim and respond to be far more aggressive to try and keep those servers from ramping all the way up. So you can do it as a nonlinear response, and that's another thing we like about trim and respond.
Mm-hmm. Yep. So this was just, you know, for another way of looking at that or doing that. But again, I don't see any problem with the way you're trying to do that there. That was just a continuation of the comment in there.
Okay. Well, that's the last of the comment I've got there, and I apologize for having this upside down.
Well, you should see what we're doing in our offices.
Yeah. Yeah. Well, I'm actually in Australia. I'm standing on my head.
There you go.
All right. So, if you wanted to talk about any of the other comments, I'm happy to do that. And again, I apologize. I wasn't quite aware that we were addressing this comment, and I set up for all the other ones that we received from you. But I definitely appreciate you taking the time to read the document, for providing the comments, and certainly for taking the time to explain your thoughts about this. And I've got some notes here I'll share with you and share with the rest of the committee.
What I'm likely to do is find a spot on Stuart's calendar. I did invite him, but he was not able. This is short notice, and so ideally in the next couple of days or so, I can even set him up on a private session. It doesn't have to be interactive, and he can just dictate. But I think I transcribed a lot of his material, and it should be obvious that somebody who doesn't do controls every day transcribe them. So if it doesn't happen, then at least you have David's comments, and we move the ball a little further downfield, I feel, with the time we spent here today. So then thank you for your time, Mark.
Yeah, it's fine. Well, if it works out anytime between now and Thursday, I'm available. I get on a plane on Friday to get out to Atlanta.
Mm-hmm. Okay.
And in fact, I could conceivably do something on Saturday since there's no committee meetings.
Okay. Well, it is true that this comes at, I guess what I'll do is do you mind if I cut back to my screen again?
No problem. Go ahead and take it.
We're ready to close the call right now then, so we're up to half an hour, that's fine. I do that, I'm mindful of it only because I'm dealing with terabyte size files when I have these transcribed into Apple Final Cut. Very often I have to a 75 megabyte file morphs into a 25 gigabyte file.
I can imagine.
So you keep it, and we're dealing with relatively small lettering, and there's a lot of audio, blah 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 blah. So that's the story. I would try to keep it to about half an hour. One item, since you're here, so I'm ready to close out on this one. Just assume that we've done the best we could here. As I say, we ripped through we ripped through many documents. So you can see my next conference call is with who am I dealing with? This is NFPA. They're the tag for an international standard on cities, accessibility requirements. I've got to deal with eye washes tomorrow. I'll be dealing with aluminum copper wiring. All right, so that's the this since you're in California, this is interesting.
I actually don't see your screen
We
yet.
don't.
No,
I'm sorry. I think let me go over here. Let me see. Can you see?
Definitely got the presenter, but you haven't shared it yet.
Oh dear. I guess I have to say yes. Thanks for speaking up here. So how
That's
come
good.
I'm not? Oh, that's David. I typed the wrong. I have to be me. I'm going to make myself. There we go. Okay. All right.
It says waiting your screen. Oh, there we go. Good.
There we go.
Yeah,
All
I see
right.
it now.
So, long story short, we go through a lot of these, and I that's why I say we move at a very high hit rate, so to say, and we figure if we get half of our commenting opportunities based on all the stuff that's coming at us. I stopped here since I learned that you were in California. This might be a separate discussion. Of more importance to me, however, and I want to get to that right now, is a statement that we received from ASHRAE not too long ago. And I'm going to guess, if you don't mind, I'm going to turn my screen off because you're going to see some email. Some of my people are rather passionate about codes and standards, so I don't want them to be embarrassed by anything that might be on the screen here. So let's go. ASHRAE changes the standards process, and okay, so here we go. Now I've got this here. So again, the fact that you spent the time with us is we're very grateful, and we'll say cool things about your leadership and such. Is there any backstory to this particular development, which is just within the past since the 10th of June? What do you know anything about this?
No. I would send an email to Stephanie Renich, manager of standards, and ask her.
Mm-hmm. Okay. All right.
Or you could use that email that they've got down there, standard section at ASHRAE. Oh, except it looks like you want something.
It's Rick Hall. Is that you can't see this, right?
Yeah. It says that Rick Hall is the current chair of the standards committee.
Yeah. Okay.
It's a really difficult process. I've done 2 tours of duty on 90.1. I did the 1999 standard, where we were fighting for our lives to keep the ANSI accreditation, and we had the whole electric utility industry bearing down on us. It was a very difficult time, and then the 2001, I think, is maybe 2011 standard. I can't remember which one. But that's the one where it was 2011. We added process, and I was vice chair under Mick Schwedler, and we had an appeal from the data center folks, a last minute appeal, and the amount of people hours to deal with that appeal, and just kind of the way that went about was one of the it was a huge burden, not only on the ASHRAE committees, but also on the volunteers.
Oh yeah, I'm not. I don't. I want to. One of the benefits of the fact that I don't of ripping through this the way we do is we don't get too emotional about one particular standard suite. We figure that hell, you can win World Series with I don't know what I think World Series winners, what, will they win 60% of their games? Is that,
Right.
come on, people. So that's why I generally don't get too nutty about this, but it was
But you,
noteworthy. And I'm concerned that incorporation by reference is going to be causing, it's going to be causing problems for standards developers because I'm going to get back in, we did a little talk on this. You can listen to us, incorporation by reference, and we should go back to about here. Yeah, go back in March. I'm concerned that the revenue stream for standards developers is threatened enough by incorporation by reference that we're simply not going to get the technical committees with the time and the support from the SDO to do a good job, to dick her around back and forth, kick ideas back and forth, to discover leading practice, like is what you and Dave just engaged in, was leading practice discovery. I'm afraid that we're going to see our standard system compromised because the standards developers can't be in business. I see the same thing at NFPA. I've been on the NEC for almost 20 years now, and the NFPA has entered a new type of process where there's less. The technical committees have a lower bar for rejecting a particular idea, and unless there's a more argumentation going between submitters and the committee. Granted that most of them are, those codes are set up not to be changed. I get that, but you still need to keep these guys in business. So I just thought, since it's going to be recorded, and I know Stephanie, that we're no enemy to the standards developers. We want to net out to keep our 2 to 3% gain that we think we add to our industry. So that's my long way of saying I'm on your side mostly.
well, I'm, again, I like the ASHRAE process. It works. I've been in the trenches for, more than a decade on this, and I've seen what other standard bodies do, and I think the ASHRAE process is about as open and inclusive as any process I've seen.
Yeah.
So and the staff there, yes, everybody makes mistakes, but they're about as good a staff as I've ever had the privilege of working with.
Mm-hmm. You could release, if I were to ask anything, I'd like to be able to do more collaboration with my colleagues around the country. It would be nice to get a hold of, find out who the actual members are. For example, are you allowed to release other universities and other user interests on your roster of votes?
What do you mean? You want to know who's members of the committee, or?
Yeah.
I don't think that we're allowed to release their data, as in their, contact information.
Well, no, so I get that. That's why I don't want to put you on the spot. You're not the only standards developer that keeps technical committee members, even their identities and who they are, or even who they vote for.
Oh, I don't mind naming everybody that's a member of the committee. I just don't have that offhand. And if I was, if you're interested, I mean, we got, I think, 22 members and corresponding members, and they cover a very wide range. I know most of the voting members by name, but I just don't want to open up a roster.
I get that. No, you don't want to do it. And it's not our intention to. Yeah. We would be working behind the scenes to build relationships with like-minded, and we're going to be advocating the public sector user owner final fiduciary. Now that's different. Remember, the final fiduciary is probably not the enforcement interest, and that's why we're very careful to say large organizations like ours, there's a guy that's ultimately footing the bill for all this, and the enforcers are actually working for him. So that's what makes campus systems a little bit different, especially the larger ones. So long story short, it'd be nice to get a roster of the committee members and how you classify them. And if you're not, don't be embarrassed, because we run into this with everybody. We run into this with everybody. Makes it hard to develop relationships.
Yeah, I can't remember if we've got it up on our site, but certainly the names of the committee members are, actually, if you download any of our minutes, you can see who's attended the meetings.
Mm-hmm.
And they're all on our public website.
Yeah, okay. So there's something here that we could look a little bit harder. I will say for NFPA, they do have the gold standard for identifying who the interest is, and since the world will basically see what we're talking about here, I thought so here would be an example of how I think all of the standards developers would do it. But so here's the technical committees, and here would be me, for example, right up here. You know my email address, you know how I'm voting, and there's thousands of people, tens of thousands of people doing this, and we would like to be able to know who our counterparts are elsewhere. If not for no other reason than we think we can have data, we can put data and organize our data gathering. That's what my next teleconference is all about. It's all about, go ahead.
The names of the committee members and their votes are recorded in, like, again, in 90.1, and in all of our votes, we've recorded the names and who voted. But we're just really conscientious about not putting in address information for.
No, it's not address information. I don't mind hunting around for it. It's who they are and what interests they represent. Is the committee balanced, for example?
All right. So there is there's a bias and conflict form that every committee member for every committee in ASHRAE, every member that is a member of a standards committee or a guideline committee fills out, and those are available from staff.
Mm-hmm. Okay. Well, that's right. I understand. We've actually done that. I have this list, for example. So I pulled one up so the world can see what you're talking about. I get that. It's just that when you go to NFPA, it's right. It's right there.
I agree with you.
I can call them on the horn. I can say, "Oh, you're a utility, huh? I'll email you. Let's get on the horn here. I think I have some data that might support your case, or I have data that refutes your case." Generally, it has to do with the collaboration likelihoods and seeing where we would put resources, for example. So, for example, here's the 90.1 committee. How are these people voting? And are any of them on a college or university? Are any of them on a college or university directly employed by one? How could I tell that from this? And of course, you can't. That's my point. So
if you look up the minutes from the 90.1 committees, you can see the votes. I'm pretty sure they've got all of that stuff available off the public.
Okay, well, it's just laid out differently, and I also get that too. So, so I don't want to belabor the point. I think you get it. We just have to. I have somebody helping me research this, so you can actually see now that it's just done differently. And when you're dealing with 50 of the main standards developers, the way we do on a near hourly basis, it's helpful. That's all. That's all.
Yeah, no, I appreciate the fact that you guys are so involved in standards.
Well, a lot of these organizations aren't used to having the public sector user interest. They're still trying to get used to the idea that we're actually sticking up for ourselves. So anyway, well, look, you've been very helpful and generous with your time, Mark. I'll upload this on YouTube, and if there's any reason you want me to take it down, please let me know. It's probably better to do this faster, so I may not go through a Final Cut. I may just upload it on this particular page. And and so that means it has limited access. And then if there's any reason not to, I can easily take it out. So I'll probably put it right down here. Probably within minutes, it'll be there.
Just if you don't mind sending me a link, that'd be great.
Yep.
But the other thing is that when Stuart's ready to go through his comments, just again, I'm open till. I leave on Friday, and could possibly do something on Saturday.
Okay, that's great. I have a feeling that I've taxed our mechanical engineering staff quite a bit lately, and they're all acclimating themselves to how often relevant standards, how often they change and how important it is to follow it. And so it may be a matter of simple resource rationing. I'm very grateful to have David's expertise. As you can see, his video clips tend to be the ones that people want to see the most of. If you go back here, I think he's the one that's got the record. He's got 162 views. I don't think I've ever owned. Hell, I even known some heads of state that don't get that many views. So anyway, hey guys, thanks very much for your time, and let me know if we can return the favor somehow, Mark.
All right. Well, just keep us, we appreciate the experience you guys have, and keep commenting. We're going from an advisory public review now into the next one will be for publication. And the idea of doing the advisory public review is just to let people know that this is out there. And the next one's for real. We have to respond to each and every comment. On an advisory public review, every comment is considered supportive. But we're not going for publication yet. That's the next step.
This is the big document. This is probably one of the most, I hate to use this word, impactful of the ASHRAE suite, I think, this one here, because there's a lot of product, service, installation, and maintenance money. A lot of money involved in this one. I get it.
Yeah.
Okay.
Well, and it matters. This is where the rubber meets the road. You can put in the best equipment, and if it's controlled in a poor fashion, you're not going to get the performance out of it. So it matters, and well, I'm spending all these hours on this committee. I think it's really important.
I think we're spending something in the order of $60 billion a year on mechanical systems. That's $60 billion. It's roughly 20% of the $300 billion we spend every year. As I try to remind everybody, $60 billion would be the better part of Microsoft's annual revenue.
Yeah, that's
how much is going in here. Okay, Mark. Hey, take care.
Hey, thank you all.
Let us know if we're going to return the favor. Take care. Bye-bye.
Okay, bye.
Thanks, Dave.
Yep, thank you.
Bye.